Our next speaker, Mr. Roy Schauffele, is president and founder of Division 7 Solutions Incorporated, a 25-year-old Converse headquartered architectural representative firm with multiple offices in multiple states. He has served and is serving as a technical advisor to Build San Antonio Green, USGBC Green Schools, many city architect and public works offices such as the Alamo Dome Construction, SVC AT&T Arena, Mirasol Housing Problems, State Capitol Underground Extension, re-roofing San Antonio City Hall, Main Library Rehabilitation, and the list goes on and on. So I'm going to cut that portion short and just say that he is a chemist and engineer by education, a frequent and highly requested lecturer at various university schools of architecture, and an internationally published author and speaker in the fields of roofing, waterproofing, insulation, air barriers, and building exteriors in general. He has held several patents. So please welcome Mr. Roy Schauffele.
Thank you. I'm very complimented by you folks being here today. I thank you for that. I see some very friendly faces in the audience. I do want to thank the UTPA Office of Sustainability for having us down today. We were asked to come down and bring you up to date on a variety of things. Number one, how all the new codes, and do we have any general contractors in here today? Buy more liquor, okay? All of your codes are changing drastically. They're all feeding into the green program. If you think the changes of 2009 were tremendous, 2012 is even more thorough and more deep. In that regard, I wanted to cover several items today as it pertains to the building envelope because, like my presenter before me, much has changed in my field of Division 7. I will cover off on all of that today. And if you have questions as we go along, feel free. This is a registered provider program for AIA. It is HSWSD rated. That will count for your state relicensing in Texas. It is also a LEED CMP program for the LEED Green Associates, LEED APs with or without specialty. Please copy the course number down. You've got to do your own self-reporting at this point. And now we begin. Through-wall flashings. When I came into Texas 25 years ago, 70 to 75% of all the problem jobs I was involved with related to roofing. That same 70 to 75% now relates to wall problems and through-wall flashing. The lawyers are very happy that we're all in the construction business, as the general contractors will attest. But what I'm going to go through quickly today, and there are some mock-ups outside that you'll see over the lunch break that the Innovative Block and STS Coatings have erected. We've actually shown you some of the mock-ups how not to do it, because certain habits and traditions will die. So today we're going to go through the purpose of through-wall flashing, understand the criteria and how to specify through-wall flashings for your building performance. Understand the attributes of the commonly used materials that are current on today's marketplace, and understand the compatibility issues between cavity wall components. Folks, with the changes in the codes, your entire world and universe has changed. I don't expect you to be a chemist, but you cannot bring certain components together in the wall without a failure. As a general article, I urge you to go back and read the April 2004 Construction Specifier magazine on the last page under the heading of failures. Wish Janie Elsner at that point had printed up quite a bit of data on what you should not mix and match in a cavity wall, and it's going to get worse. How to design a successful drainage system. Design, including details, is critical. Material selection nowadays has got to include compatibility, sustainability, performance, i.e. long-term performance, and construction. I will tell you that probably 80% to 85% of the walls I look at in Texas, the through-wall flashing is not installed properly. That's it in a nutshell. I'm not knocking anyone, I'm telling you what I see out there. The design attributes of flashing, and I like to bring a lot of third-party data to presentations such as this, and in that regard, the Masonry Advisory Council has excellent guidelines for you. It should be water imperviousness for the material. should not be affected by water. Well, for years we used organic felt or 15-pound tar paper in there. Resistant to damage during construction. That means puncture, tear, sunlight, and UV burn. And I'll share with you something new I ran into the other day. Should not cause discoloration of the brickwork. Well, folks, some of the incompatibility issues in there do cause the problem. And if you start to have those problems, you will wind up with leaky windows and leaky walls and a subsequent mold infiltration problem. It must be compatible with all the adjoining adhesives and sealants and everything else it contacts. I am not going to single out any product here, but if you ever picked up a tube of 1 part polyurethane caulk and sealant, readily available in the Valley, 1 part polyurethane, on the label it reads, do not bring into contact with asphalt, coal tar, or vinyl. And where does everyone use it down here? Asphalt roofing, asphalt waterproofing, and as a seal for vinyl windows. And it's printed right there on the label. Life expectancy of the flashing material is a critical decision point. You must match the life expectancy of the flashing to the life expectancy of the wall and of the building. The Masonry Advisory Council talks about the prohibitive cost of replacement. Flashing is one construction material that you should never, ever select solely on price. You must select it on installed cost and match it to the expected life of your building. In that regard, this is a picture of a rather famous convention center in San Antonio. This is a lawsuit. It's a big lawsuit. They're replacing that flashing in the wall at $163 per lineal foot. Only in San Antonio would they award that contract to the original installer. Okay? Sometimes it's unbelievable what happens. Best practices, I can only urge you to do your product research. Take a very informed position. Be specific with your material selection. Once again, and I stress, match the lifespan to the lifespan of your building. Value engineering, boy, in this market there's a lot of that going on. And you need to be ready, willing, and able to defend your position. Because what I'm saying here at this moment is going to feed into the bigger code changes and the bigger lead changes that are coming up at the 11:30 presentation. This is only the beginning of your migraine. You're going to get a full-blown migraine when you realize what's going to happen by the end of the year. Your cavity wall components are air barriers. Air barriers are now code. Legal interpretation is that ASHRAE 90.1 2010 that went into effect September of 2010 and is the basis of all codes is a legal document enforceable now. The things that ASHRAE 90.1 2010 have affected are LEED version 3.1 2012, out today for the 3rd public comment period, due to be published in September. The IGCC, International Green Construction Code, that particular code has been adopted by 17 states already. And in that regard, it's not even published. It will not be published until the end of the month, and 17 states have adopted it. And of course, the International Energy Conservation Code 2012. That should be out in June. The original comment period for that had 63,000 comments. You could tell the difference in the trades that made the comments. If it was a general contractor comment, it normally was 1 or 2 lines said, this will not work and it costs too much. If it was an architectural comment, it was about 3 or 4 paragraphs long. So it was very unique for me to go through those and see the comments that were out there. But it will be code, and you must be careful, or you're building a tremendous liability into your wall systems. The types of air barriers that will be out there will be liquid applied, which include asphalt, acrylic, and silicone. Please do not specify an asphalt-containing air barrier. I will cover off on that in the next presentation. The membranes will be asphalt and butyl, sprayed polyurethane foam, and building wraps and papers. The cavity wall components will now include insulations such as polystyrene, polyisocyanurate, spray polyurethane foam. Sealants currently being used are mastics, emulsions, butyls, polyethers, polyurethanes, and silicones. It's a big chemical mess out there. I have the honor of being on the Air Barrier Association of America Board of Directors. I serve as chairman of 2 committees. Because of the need for the chemical knowledge to be shared with you, we have just had an emergency session 3 weeks ago and formed the Terminations and Flashings Committee. So we're trying to get ahead of this problem immediately. Through-wall flashings, the least expensive one is PVC, polyvinyl chloride. PVC flashings used to be a great product when they were made by the Neverstrahl Company out of New York. They were 60 mils thick. And as those of you who know me in this audience, I am of Italian descent from South Philadelphia. I must have something in my hands to speak from, and I will probably wander away from the mic and you're going to have to bring me back. This is polyvinyl chloride. The BIA, Brick Industry Association, that's another one of your Bibles. Their tech note number 7A is on our website. BIA says minimum PVC 30 mils thick and is for short-term buildings. That is my arm in that photo. That is an 18-month-old piece of PVC flashing. The building leaked like a sieve. This is PVC. If you wouldn't mind passing this around. Thank you. Peel and stick flashings. You know them typically as the W.R. Grace product. It's a polymer modified asphaltic material. Excellent, and the architects like it because it's self-healing. Contractors like it because it's 60 cents a square foot. Material cost, not installed cost, material cost. It's a good product. You should use it around all of your fenestrations, but everybody, and you have the literature in your kindly provided by the Office's Sustainability Packet, how it's supposed to be installed. Peel and stick flashing is to not span a gap of more than 1/4 of an inch without support. As you can see in this particular drawing, it's already troughing out and starting to sink down and fail. You're supposed to have a physical support across there. Do be advised that the provider of today's program manufactures and sells all the types of flashings I'm going to be pointing out on the pro and con side. So you're getting a very balanced presentation today. You must prime the exterior surfaces. You must install termination bars. This is mandatory by every manufacturer and it's listed in the data given to you. UV sensitivity, some people are 30 days, some people are 60 days. Once you go past 60 days, SBS, styrene, butadiene, styrene. If a product has the name styrene in it, it will be quickly, rapidly, and irreversibly adversely impacted by ultraviolet irradiation, i.e. sunlight. Heat sensitivity, many architects like this particular product because it is, quote, self-healing or self-annealing. In that regard, it gets that property from undergoing cold flow. It will seal around. It moves with heat. It's a thermoplastic. And you also have, asphalt compatibility issues. Asphalts are not mutually compatible. If your damp-proofing on your wall is from a Venezuelan crude and your peel and stick is made with a mid-continent asphalt, I assure you, you will have an incompatibility reaction. The incompatibility of asphalt being 4 fractions and 275 different compounds, is horrendous. That is why every major shingle manufacturer who makes a self-sealing shingle has a test called the Oleensis test to ensure compatibility of the asphalt even that they make. So it's a critical, critical issue. Your Bible should be BIA Tech Note number 7. Select the flashings that are waterproof, durable, UV resistant, and compatible with adjacent materials. Again, the word compatibility. Use a metal drip edge to extend flashings that degrade when exposed to UV. In this particular case, the stuff that's coming out is called, and this is a high-tech statement, drool, D-R-O-O-L. It's from Penn State. It's a term they developed up there. And that is where this material was properly specified, properly installed, and it still underwent that cold flow property, which is what we like for the self-sealing capability. Once again, great product to use around the windows, not in through-wall flashing. EPDM is a northern, i.e. New England, Mid-Atlantic, new effort. The EPDM manufacturers, this is the same material that is used in roofing. It's a good material. It's not a great through-wall flashing material. It's multiple component on the installation. It has a dimensional stability problem because in 100 lineal feet, it can shrink 2% or 2 feet, which it means that within 100 feet, it's pulling in, and you will wind up with a gap there. It is also incompatible with asphalt and several other materials in the wall. EPDM, once again, cannot span a gap of a 1/4 inch, and it has some serious compatibility issues. I wrote an article in 1996 called Roof Warranties, Panacea or Loophole. I heard from every corporate lawyer in America, it didn't matter who the manufacturer was, they all sent me nasty notes. At that time, that's okay. I have ex-wives, I like nasty notes. I had at that time there were 26 exclusions to a roofing warranty. There are now 38, including, strictly for Texas, insect infestation, fire ants. The EPDM backbone is very similar to cornstarch, and fire ants like cornstarch. They got to be one tough species of ants to eat this stuff, but they have. So be aware of the good and the bad of everything. The PVC KEE is a great polymeric material. It's a trademark of the DuPont company. It is resistant to many different chemicals. It has worked well in roofing. It is a material of choice by a lot of people. But that was before the air barriers came into play. Now, PVC, peel and stick, and PVC KEE are all called thermoplastic materials. They're synthetic materials. They are man-made. In that regard, since they're thermoplastic, they are deformable by heat. So on a job site, you can get that drool, or if there's another heat component next to it, like a 2-component polyurethane, spray foam, you can indeed melt these materials. Just be aware there is no panacea answers for synthetic materials. If there is a panacea for an answer for through-wall flashings that's going to match the life of your building, it's going to be galvanized, stainless steel, or copper. Why? They're rigid, they're inert, and they're not man-made. They're God-made, and they last a long, long time. The PVC KEE has the polymer in there, and a great polymeric development by DuPont. But in lieu of plasticizer, it has the KEE. There are 2 versions of it out there, but once again, I go back to any synthetic material that's a thermoplastic. It cannot span a gap of a 1/4 inch, and this is in their literature. Everything you see here is a literature review. They have heat issues with sprayed polyurethane foam, and it has very low puncture and tear resistance, as does all the synthetic materials. The copper flashings, now we're into where lead and green and recyclability can play very, very large. Copper is a material, it's a monumental metal. Longevity is unquestioned. Cost is questioned, but longevity is not questioned. There used to be asphaltic copper products on the market. They had the very same problem that the peel and stick membranes did. Almost forgot to pass this around. Thank you. Drainage plane flashing has taken a lot of the coastal areas by storm because it is the same copper type product and drainage system all in one. A one-piece flashing. Now, I need to be very sincere. There is a habit in the Rio Grande area. It goes from Del Rio, Eagle Pass down to Brownsville. It is a habit of tucking the flashing into a CMU wall. You can no longer do that. You can no longer do that. There are 2 reasons. One, if you do that, you've just violated the air barrier integrity that's costing you $2.50 to $4 a square foot on the wall. Number 2, if you tuck it in with the new flashing drainage management systems, you're now putting water back into the building. That leads to mold. You now have an IAQ problem, and you have a waterproofing problem. Are any of these products green? Yeah, I will tell you, they've done a great job on all of these technologies on recycled content as manufactured. PVC, copper, and drainage plane have well over 80%. In the case of copper, well over 90% in recycled content. Are they recyclable at the end of their lives? Many of them are not, some are. And what is the maximum warranty? In published literature, the maximum warranties vary from 5 years to 10 years to lifetime. There are some products out there that I have read on the back, they basically get a tail light warranty. When you can no longer see the contractor's tail light, the warranty is over. And that's about the size of it. But everyone's driven by cost nowadays, and just understand that people are making choices based on that cost, based on the ability to keep their firms alive, based on the ability of the building owner demanding that an architect bring a project or a school in under budget, and that budget might have been established in 2008. So we're dealing in a very strange time in our business. So you do have variations in warranty and recycled content. Are they chemically compatible in the wall? Some are and some aren't. That's a Rubik's Cube. I am the oldest of 5 children in Philadelphia. I have one of those kid sisters. She's 16 years younger than me, February 29th baby. She can do a Rubik's Cube in a minute and about 45 seconds. That's disgusting. I showed her though, if you get your hair dryer, you can soften every one of those tiles and move them where they need to be. So in that regard, as you're dealing with the Rubik's Cube situation on your job site, keep this chart handy. The compatibility issues, as will be further illustrated by the 11:30 presentation, are huge and growing, and if you're not careful, you're building a lawsuit to begin with. The accessories, I can tell you at this stage of the game, the accessories are going to remain the same. Some things will change, but you have termination methods, different manufacturers do it different ways. You have sealants, end dams, corners, mortar deflection devices, and weep devices. Make sure that everything comes from one source. In the case of even something as small as that termination bar that's shown there on the left-hand side, the white piece, that's about 100% recycled content. Can you pass that around for me, please? Thank you. And all these things are going to feed into your material usage on your lead programs. Terminations, do not tuck your termination. No longer should you be tucking your flashing back into your CMU. Because of the advent of all the code changes and the inevitability of them coming into practice by the end of the year, if you open up that wall, you have destroyed the integrity of the air barrier, and you will fail the air barrier test. The Corps of Engineers, Department of Defense, Navy facilities are already requiring surface mount materials which look like this now. Termination bars, you have choices of stainless steel, aluminum, plastic, PVC. Please do not use aluminum in your cavity wall. That alkaline content will knock it right down and cause quite a bit of white rusting and failure within about 4 years. Sealants, be very careful. They're a whole new set of chemistry. The young lady that presented before me talked about the low VOC sealants that they utilize. That is part of the new LEED 2012, version 3.1. And a lot of material that you used to know will no longer make it. It has been admitted by many of the polyurethane manufacturers that they are reformulating right now because their old formulas will not meet the new codes and new requirements. Sealants, just to give you a broad scope look at how they perform, the shear strength of mastic is 3.4. Please don't use asphalt mastic anymore. The silicones are about 25.5, 1 part urethane 63, and the polyethers are about 89 to 90. The polyethers are the new generation of sealants. They're very low VOC. They are cost competitive with everything else in the marketplace, and been in Japan for about 20 years at this time, and in the United States for about 10 years. Make sure you take a look at everything. When you specify an air barrier, through wall flashings are not part of the air barrier specification. It's not part of the testing. It's not part of the requirement. So taking an air barrier, say from a Wall Guardian air barrier, and matching it with a WR Gray spitchethane through wall flashing, you're going to have a failure. Open joints, A lot of people have a lot of problem with joints, but I ask you to take a look at the number of joints in the wall. This is a problem area, just as it used to be in roofing. The more joints, the more leaks. It's that simple. I was involved with redoing the IRS building in Austin, Texas. IRS building, I figured I'd pay it forward a little bit so they would lose my number and never call me. We did that whole roof. Everyone was very happy, and I literally raised holy dickens on that job, and I had them pig off the roof, sausage it off, flood it with water. We found about 220 some leaks when 2 inches of water height was on that roof because of the seams. So if you have a seam, you're going to have a roof leak somewhere. In the wall, the more seams you have, the more lap joints, the more leaks you're going to have. And this is some of the different number of lap joints that you will have in your cavity wall. Lap joints, making them, most of the manufacturers will have someone to train the contractors, especially if it's a metallic flashing. End dams and corners, they are mandatory. And with certain systems, you must have a bare metal end dam or a bare metal inside-outside corner to adhere to. The flashing drainage systems, no matter whose it is, can't be lapped to itself because the water will just follow around. So you have to go to bare metal and provide a full termination on that. I like what the industry has gone to. I am probably older than just about everybody in this room. Not everybody, but I think I'm older than most people in this room. And in that regard, I like the color-coded metal. I have had 11 knee operations, 4 back operations. Climbing a ladder is an adventure. I can see the red from the ground. I can see the green for 7 ounce. I can see the red for 5 ounce. I can check out your specifications visually. It's a nice feeling. I've got young guys like Danny Loon in the back and Aaron Wood. They can go climb the ladder. They're young. Weep protection devices, many flashing systems such as the PVC, the EPDM, peel and stick, KEE, all require the use of mortar net. This has now become problematic. Mortar net is a great product. Fantastic. It answered the need of the industry for over 16, 17 years. The problem comes in this year, continuous insulative sheathing is a requirement in your wall. And if you have that, and this is your wall prior to your veneer, if you have it, where are you going to fit the mortar net? So many people have gone to the flashing drainage system all-in-one. The mortar deflection devices will probably see their sunset coming, and slowly but surely they'll go out of the marketplace. There are 3 flashing drainage systems on the market, one made in Comfort, Texas, one made out of Maine, and there's another one out of the Carolinas. It's just interesting to see the changes because mortar net was the answer to all of our drainage problems for years. This is just a different version of a mortar deflection device, but as you can see, with our requirement now to be 2 inches thick on the insulation, that's no longer going to work and it's no longer going to fit in there. Installation, don't lay your flashings down dry. We reviewed that on the mock-up yesterday. And as I said, we left a few things on the mock-up from Innovative Block and from STS Coatings that you can take a look at. In summary, folks, your through-wall flashing decision points. What do you expect? What you expect is the material to perform as long as your building's going to be there. It must be strong enough to survive installation without punctures or tears. There's a reason that's in there so many times. I was on a job site the other day where there was a synthetic, I will not identify it as synthetic polymer or synthetic flashing material used. It was leaking. I could not determine where the leak was. We had to begin pulling bricks out of the building to find out where it was. And when I looked at about every 2 to 3 feet, there was a 30-degree angle gash in the very soft polymeric material. After sitting there and looking at that for an hour, I figured out what it was. It was the mason. Those steel trowels get so very, very sharp, you could shave with them. And in that regard, that gentleman was feathering out full brick. As he went by that synthetic flashing, he was slashing it. He couldn't see it, but he was slashing it. That's going to let water into the building, going to destroy the insulation, going to promote mold growth, ruin the indoor air quality of the entire building, and ruin the integrity of a very expensive air barrier. With that, I urge you to take a look at the critical properties on a job site, i.e. tensile, puncture resistance, and the laps required per 100 lineal feet. All of this is in the company's literature, the manufacturer's literature, and I don't care which manufacturer it is, it's there. Longevity, your choice, match it to your building. Maximum warranty, your choice also, but pay attention to the chemical compatibility issues. Puncture-resistant tensile are critical to quality properties of through-wall flashings. They are measurable and they are comparable. Add longevity, compatibility, and ease of installation in the selection criteria and increase each of these values as the life expectancy and complexity of the project exists. You need to be aware of all these things. It's not the same world, folks. The world begins to change drastically this year. Completely drastically. And I can only urge you, keep your buddies' numbers handy, get a reference source. There are architects in San Antonio that now keep lists of the people they can go to get technical information and technical data. Third party, I urge you to start developing them because it does all change. Now the big question I always get is, what costs what? It seems to be a favorite question for bidding purposes. I can tell you that the metallic materials such as copper, stainless steel, and aluminum are very, very expensive. Material cost, they're very expensive. The KEE, the PVC, self-adhered peel and stick membrane are inexpensive material cost. But that's not the full story. With everything you're dealing with, we did some work with the unions up in Boston. So don't accept these figures as absolute numbers. Accept them as a comparison. A lot of my, how do I say this? A lot of my Italian side of the family is involved with the union. Not necessarily workers, but they're involved with the union. And we get a lot of numbers from these guys. If you looked at a 24-inch wide peel and stick, it's going to cost you $1.04 per lineal foot. Why 24-inch wide? Because all of your flashing, if you're using mortar net, is supposed to be 8 inches above the mortar net, just like it is in roofing. Your roof flashing, parapet flashing is always 8 inches above the field of the roof. Same thing in through-wall flashing. Your flashing, mortar net here, it's got to be 8 inches above. Mandatory by the manufacturer. Stainless steel drip edge, $1.57 a foot. Term bar, primer, mortar deflection device. So, what does your system cost? Your system material cost is $6.29, call it $6.30 per lineal foot for all the synthetic materials. Your metallic materials, like the flashing drainage system, are going to run you $4.40, $4.45 per lineal foot. Installation, and by the way, since this is an AIA learning unit, I am required to tell you that if you give me your business card, I will get you a copy of this. As you hand me your business card, I take American Express and Visa also. Okay? Just kidding. Just give me your business card and I'll get this presentation down to you. Peel and stick membrane, because it does take a lot to lay in, and it does have 17 lap joints per 100 lineal foot, cost a lot more labor-wise. So your bottom line on the cost difference, yes, the metallic materials cost more material-wise, but properly installed for warranty purposes, the copper, the aluminum, the stainless steel type of flashing systems will be anywhere from $2.50 to $3 a lineal foot installed, below the cost of a properly installed synthetic material. And I think that covers everything. Are there, oh yeah, one thing you want to look for, you did a great setup job for me. Thank you. If you're working on a school, make sure that the materials that you're requiring are Green Guard certified, i.e. her wall system and materials. In this case, different products and sealants, because that all adds to the indoor air quality and allows you to build up towards your points on a LEED building. And The company, the provider of this, also will provide you with a specification checkup if you would like it, including a lead analysis. I have these things online. More than glad to do it for you also. Are there any questions? Will Penn State have a good year this year? Yes, they will. We have someone who actually believes in throwing the ball. Folks, any questions at all? Then I thank you kindly for your time and attention. Appreciate everything. Y'all take care.